Okay, this is your professor, Dr. Cabrera, for microbiology. Now we'll be discussing the second part of the RNA viruses. Okay, and this lecture will cover all the rest of the RNA viruses. So today we'll be talking about actually from the negative RNA, this group from the envelope, and the positive negative RNA, the double capsid. So your viruses and the positive DNA, RNA via your DNA, your retroviruses, which are envelope. So we'll be talking about arena, bunya, philo, orthomixo, paramixo, and your rhabdoviruses. So let's start with the most common would be your rhabdovirus. Okay, so rhabdovirus, filovirus, and arenavirus are all zoonosis or viruses that are transmitted from animals. So your rhabdovirus, the classic form would be your rabies virus. The rabies virus is characterized as bullet-shaped virus with an enveloped helical nucleocapsid and single-stranded negative RNA genome. These are usually found in dogs, rats, skunks, raccoons, which are the major reservoirs of this virus. The saliva from this infected animal through their bites or in aerosols from infected bats via inhalations are the mode of transmission of such virus. The rabies virions bind to this is the pathology. It binds to the acetylcholine receptors on the muscle cells at the site of the bite and enter the target cells by endocytosis. And later on, it will have an incubation period, which later on will depend on the dose and at the site of the bite with the proximity to the brain. So this is the table that shows us the progression of the rabies disease. Okay. Usually it is divided into the incubation, the disease phase, the symptoms, duration, and the virus and antibody status. The incubation phase, usually it has no symptoms, ranges from 3 months, 2 months, 60 to even a year after a bite, 365 days. It has low titer virus in the muscles and there's no detectable antibodies. After the incubation phase will be the prodrome phase. It is noted to have fever, nausea, vomiting, so it's nonspecific loss of appetite, later on developing headache, lethargy, and pain at the site of bite, even if it is already dry. So the duration of the prodrome phase is around 2 to 10 days. In the prodrome phase, there is high titer, okay, of the antibody, of the virus in the peripheral nerves and the CNS, still no detectable antibody. Then after the prodrome phase will be your neurologic phase. And here, the patient will exhibit hydrophobia, pharyngeal spasms, hyperactivity, anxiety, depression, any symptoms, loss of coordination, paralysis, confusion, and even delirium. It lasts for 2 to 7 days. Now, still the virus has high titer in the brain and other sites. And in the neurologic phase, it's the only phase that you can see now, detect no antibodies in the serum and in the CNS. And later on, the last stage will be the coma, wherein this can have cardiac arrest, hypotension, hypoventilation, secondary infection may set in, and eventually this will end up in death. It is 0 to 14 days after the neurologic phase. Unfortunately for virus, having the virus enter the CNS means 100% mortality. So how do we get it? The samples is the analysis of the brain of the biting animal. So you decapitate the animal and bring it, put it in the head in a bag of ice. Then you have to transport it to a center can that specializes in rabies. Okay. And here they will see negative bodies or intracytoplasmic inclusions are found in 70 to 90% infected brains of both animals and humans. So it is very important to have a pre-exposure vaccination of pets and high-risk personnel, those like your veterinarians and animal handlers. Thus, the pre-exposure means they are not bitten yet. But post-exposure prophylaxis, those who are already bitten, okay, if you give vaccines, immediately this can prevent disease in infected people. What is highly encouraged is to do an immediate cleansing of the wound, which results in will reduce in viral load. You can also give passive immunization with equine anti-rabies serum or human rabies immunoglobulin that can provide protection until the antibodies from the vaccine will be produced. And also it is recommended to give anti-rabies to pets. So aside from rabies, we also have other zoonotic viruses like your filoviridae. And here we have your Ebola and your Marburg viruses. So for these are long filamentous envelope viruses with a linear negative RNA genome. Transmission is from monkeys to humans and also among humans by contact with infected body fluids or by accidental infection. This causes tissue necrosis in the liver, lymph nodes, spleen, and lungs. And just like your COVID, it initiates a potent cytokine release called cytokine storm. Your Ebola and Marburg virus viral disease are also called your African hemorrhagic fever. Usually they start as a flu-like symptoms with headache and myalgia or muscle pain, and later on followed within a few days by nausea, vomiting, diarrhea, possibly a maculopapular rash. So there is extensive hemorrhage, especially from the gastrointestinal tract, which results in edema and hypovolemic shock, with death occurring in 50 to 90% of cases depending on the strain. Your arenavirus, which can cause your lymphocytic choriomeningitis, or LCM, is transmitted through aerosols, food, or fomites, which are contaminated by feces or urine of infected rodents. So Lassa fever and other arenaviral hemorrhagic fevers, clinical manifestations will include fever, coagulopathy, petechiae, liver and spleen necrosis, and visceral hemorrhage with no sinus involvement. Usually they can treat it with the antiviral ribavirin. Then we'll proceed now to your paramyxoviridae. These are large viruses with enveloped negative RNA gene. They usually are distinguished by the types of their co-protein that they contain. Your para-influenza and mumps, they contain your hemagglutinin neuraminidase or HNF proteins, while your measles contains your hemagglutinin or HNF proteins. Your RSV or your respiratory syncytial virus contains non-hemagglutinating glycoprotein G and F. So these are your different paramyxoviridae. Your para-influenza, your mumps, your measles, and your RSV, which are all distinguished with the types of glycoprotein that they have. So let's talk about measles, which is the more common viral infection. Measles strictly infects human, and the measles has only one serotype. So it enters the respiratory tract and go to the local lymph nodes. can lead to infection of the conjunctiva, urinary tract, small vessels, lymphatic system, and central nervous system. It is a serious viral illness that has an incubation period of 7 to 13 days. But it does have a prodromal symptoms of 3Cs, your cough, coryza, and your conjunctivitis. Your coryza is a severe nasal discharge, watery nasal discharge, or acute rhinitis. They also manifest with photophobia and high-grade fever. And one of the diagnostic features of measles is the presence of your Koplik spots. These are lesions that appear on the buccal membrane after 2 days and which usually last for 1 to 2 days again. The buccal membrane, these are small lesions that have appearance of a bluish-gray grain of salt surrounded by a red halo. So later on, after the Koplik spot, there is an extensive maculopapular rash appearing 12 to 24 hours after the Koplik spots and starts below the ears and is spread over the body. So it's with a cephalocaudal movement from the head going to the toes. Usually, secondary bacterial infection can cause pneumonia, which leads to 60% of deaths from measles infection. Fatal dying of pneumonia occurs in children lacking their cell-mediated immunity. Fortunately, we have a virus against measles. It is a live attenuated vaccine given at 9 months. Okay, with the measles vaccine or given at 1 year old with your MR or MMR, and another third dose would be your second dose of your MR or your MMR. So let's talk about your mouse virus. This is again like measles. It has a single serotype that infects only humans. Infection in the upper respiratory tract spread to the parotid glands. Subsequent viremia can spread into the testes, ovaries, thyroid, pancreas, and CNS in 50% of cases. So if these organs are infected and they will be sick, they can have problem with the testis or ovary. They can have complication of infertility. Thyroid can have hypothyroidism, pancreas, insulin insufficiency, and encephalitis with your CNS. So the manifestation is sudden fever with sudden bilateral swelling of the parotid glands with parotitis and the redness and swelling with the ostium of the Stensen's duct. So redness and swelling of the ostium of the Stensen's duct, which is located on the second molar. Okay. As the opening of the parotid secretions or the saliva from the parotid. So infection of the other organs can cause bronchitis, ophoritis, pancreatitis, and this infection, which can occur after a few days of infection. A unilateral arthritis may result in sterility, and about 5% of cases show aseptic meningitis and encephalitis, or even combination of both culture meningoencephalitis, which fortunately is self-limited. Serious is a highly contagious infection which is spread through respiratory droplets, direct person-to-person contact, and through fomites, meaning through inanimate non-living objects. Contagious period begins before the onset of the clinical symptoms, like asymptomatic shedding may occur in subclinical cases. Again, just like your mouse, it has a live attenuated vaccine. It's administered along with your MMR. Your MMR stands for your mouse, measles, and rubella, which are given early childhood starting at 1 year old. Okay. Then another member of your paramyxoviridae is your RSV or your respiratory syncytial virus. This is again the single serotype. It manifests as common cold with rhinorrhea, usually as an upper respiratory tract infection. Later on, when it goes down lower respiratory tract, it can cause bronchiolitis, usually self-limited infection in infants, but in severe cases, it can manifest as air trapping, decreased ventilation, low-grade fever, tachycardia, and respiratory waves all over the lung face. This is potentially fatal in immunocompromised or premature infants with existing lung disease or conditions. So your RSV is very contagious and spread to respiratory droplets and direct contact. Most children are affected by 4 years of age with clinical manifestation ranging from mild cold to pneumonia. Maternal antibody does not protect the infant from primary infection, and the infection of adults causes milder symptoms. So you can treat it with ribavirin, your acid-specific gamma globulin, or otherwise called your Respigan, or a monoclonal antibody called the alizumab or Synagis. Now let's proceed to your Automyxoviridae. These are large viruses with enveloped helical nucleocapsid and segmented negative RNA genome, and it comprises the influenza viruses. There are three types of influenza virus, A, B, and C, and type A is the one that infects animals and humans. It's influenza A. Influenza A and their significant human pathogens. Influenza C is less important. What is peculiar with influenza is it can do antigenic shift. Okay? It changes in its capsular antigens, okay? Especially which with influenza A. So the pathology is it kills ciliated and mucosecreting epithelial cells. This results from initial infection of the upper respiratory tract. So this is your acute influenza in adults. Incubation period lasts for 1 to 3 days. The prodromal period is around 3 to 24 hours, and the disease usually lasts for 7 to 10 days. And it manifests like with malaise, headache during the prodrome, followed by myalgia, fever, and unproductive cough. Usually, what we watch out for will be secondary bacterial infection, especially sore throat, which may occur in the second week of breastfeeding. So we now proceed to the next, okay, the positive RNA via DNA, which are envelope called your retroviruses. So retroviruses has two human pathogens, your HIV, your human immunodeficiency virus, and your HTLV, or your human T lymphotropic virus. So your retrovirus will bind the binding of HIV to GP122CD4 and chemokine receptors, which is in the early phase of disease, and CCR5 in the late phase of the disease. Okay, and also your CXCR4. And after binding, there will be fusion of the virion cell membrane mediated by HIV GP41 in the choreoreceptor cells. Then there will be release of nucleocapsid into the cytoplasm and uncoating of the nucleocapsid and release of your 2 copies of your single-stranded ssRNA genome and reverse transcriptase. And there will be a formation of HIV double-stranded dsDNA by viral reverse transcriptase. And there will be transport your HIV dsDNA to the nucleus and its integration with the host chromosomal DNA by the viral integrase forming provirus. There will be transcription of your proviral DNA into genome, RNA, and several mRNAs which are transported to cytoplasm. So the synthesis, processing, and assembly of viral proteins in or near cell membrane. There will be movement your HIV genomic RNA to modified membrane and budding out to form your envelope. And lastly, there will be release of the virion by the budding of and subsequent cleavage of the polyproteins by the viral protease to yield mature virion. So this table just shows the life cycle of the HIV. So HIV is a lentivirus that causes immunosuppression and neurologic disorders. Your ELISA, your enzyme immunoglobulin acid detects anti-HIV antibodies at the standard screening test And the Western blot for anti-HIV antibodies is used to confirm ELISA tests for diagnosis of HIV infection. In HIV, there is a decreased number of your CD4 T cells in the peripheral blood and decreased ratio of your CD4 and CD8 cells, which are indicative of an active HIV infection. So, for HIV, your specific was decrease in your CD8 cells that proceeds for progression to a full-blown AIDS or acquired immune deficiency syndrome. HIV primarily affects the T helper cells, the myeloid lineage cells which express CD4 and a chemokine factor receptors. So the antiviral drug therapy delays the onset and severity of the symptoms and decreases virus production. And that's it. Okay. So thank you again. See you next study session. Please do well. And again, let me remind you, if you find this helpful, please click the thumbs up button and the notification and please share this video to your friends and to students so that they may learn something out of the RNA virus lectures. Thank you very much and have a good day.